Good morning to everybody from Washington, D.C. Thank you to IATA for organizing this conference and inviting the library to share our experience in creating a specialized display case. In this presentation, I aim to convey our approach to risk assessment, case design, and maintenance in order to safely display an object of exceptional significance. Let me be clear from the start. Our Gutenberg display case was very costly to construct and required participation from a team of experts including design, fabrication, preservation, security, mechanical engineering, and fire protection. Even if our Gutenberg case represents an atypical strategy for managing the risks of long-term display, I hope you'll find some aspects of the case and our decision-making relevant to your work. The library's copy of the Gutenberg Bible, bound in 3 volumes, is one of only 3 perfect or complete copies printed on vellum known to exist. Using pre-pandemic numbers, the library's 2 million annual visitors expected to see the Gutenberg Bible as a highlight of their experience with us. The library's 3-volume set is designated as one of its national treasures. This designation puts into effect a number of conservation and security requirements that apply to a select group of objects. We display 1 volume at a time, while the remaining 2 are secured in their storage vault. The environmental conditions of the vault are set at 53 degrees Fahrenheit and 50% RH, similar to the display case conditions. Light levels in the case are set at 5-foot candles with timed outage when the library is closed to visitors. A page turn occurs every 3 months, and each page displayed is logged to document exposure. The volumes are rotated on display every 6 months. This allows the benefit of keeping each volume closed in storage a majority of the time. The U.S. government approved the purchase of the Gutenberg Bible for the library in 1930. All 3 volumes were continually displayed throughout the decade in this specially designed case, seen here in a photo from the mid-1930s. For nearly a century, the Bible has had a featured role in the library's engagement with its visitors. Jumping ahead 50 years, while the original case was historically and aesthetically sympathetic to the Bible, it lacked modern preservation and security features required to protect against deterioration, damage from fire, and physical intrusion. In 1982, the case was modified to include mechanical equipment, which enabled display in a controlled environment. This 1982 version also included the installation of a non-aqueous fire suppression system. Where I've placed a solid orange line at the base of the case, you can see that the back was extended in keeping with the original case woodwork to accommodate this equipment. Case hardening in the 1990s included a reinforced glass door. Its increased weight affected access procedures. While not without challenges, including aging systems and cabinetry needing ongoing repair or replacement, the case as seen here allowed the Bible to be on display for over 2 decades with only temporary interruptions. Now let's zip ahead to more current times. In 2015, fire sprinklers were installed in the library's Great Hall for the first time. While no sprinkler head was located directly above the Bible, and we did not expect water to penetrate the sealed artifact chamber itself, the mechanical compartment was not designed to withstand water intrusion, and there were obvious gaps. So the probable risk was not direct water damage to the Bible, but possible compromise to the environmental security and fire protection systems required for it to remain on extended display. This juncture provided an opportunity to identify all case challenges or deficiencies as the library considered whether to replace the case. Key among these was the need for 3 people to lift and secure open the heavy reinforced case door. During an emergency, particularly if off hours, this challenge in accessing the Bible might impede response. The picture on the right reveals the equipment compartment with the HVAC unit pulled out for service. Upgrades performed over decades to the mechanical security and fire protection equipment fought for space, limited utility connections, and at times got in each other's way of operating efficiently. So a decision was made to go forward. On this slide, which lists some of the technical requirements, I've checked those new to this case design. Additional stipulations from senior management required the case be able to accommodate the temporary display of other national treasures, as well as the ability to dismantle the case and reinstall it in a different location should the library's exhibit plans change in the future. In the image on the left, the designer showed his vision for the case, drawing similarities between this approach and the situation of the Mona Lisa at the Louvre. Both rely on lines of perspective and symmetry related to the prominent architectural framing that surrounds each object. His argument for this radical departure from the old case aesthetic was to celebrate and focus attention on the iconic Bible. The look of the new case includes frosted glass mirrors as a backdrop that, combined with reflective light, provide a uniform luminescent surrounding. With an unobtrusive bracket securing its cradle, the Bible is seen as floating in the case interior. The new design allowed abundant space for all the technical equipment, a clear preservation improvement. I won't dwell on case materials or construction techniques. The point to make here is that we gave thought to the risk presented by a closed air circulation loop within a tightly sealed case. Choosing and testing construction materials was of paramount concern. Again, the modern design, featuring mostly metal and glass surfaces, worked in our favor. Testing proved that the adhesive holding the glass to the aluminum structure posed no concern. However, we reviewed and tested several gaskets before finding an acceptable product. The fabrication process involved assembling the case in the vendor's workshop for review, disassembling it for powder coating, reassembling again in the workshop with the mirrored surfaces and mechanical equipment in place, disassembly yet again for transport to the library, and finally reassembling on site. The front glass door weighs 800 pounds. With proper design and the use of highly specialized hinges, the door can be maneuvered by one person if necessary when required. I'll briefly run through some details of the mechanical compartment, starting with the HVAC unit. The relatively small mechanical unit has many advantages over other types of systems, especially in light of the amount of dehumidification and cooling that our set point conditions require. It does not produce a great amount of heat to begin with, and some of the heat generated by the system is transferred back for use in its own process. Unlike units that require connection to a water line for dehumidification or humidification, this system does not require any exterior plumbing or drain lines. We avoided concern over the glycol cooling coils icing up by selecting a temperature and RH setting with a dew point of 35 degrees or slightly above freezing. Air returns from the artifact chamber as shown by the orange arrow at the left of this schematic. About 10% of the return air passes by cooling coils, which condition the air to the correct moisture content or dew point. Any condensate not used by the system drips into a metal reservoir below. 90% of the air does not pass over the glycol coils, protecting against excessive cooling and in turn the need for more reheating to bring the air up to the correct temperature to supply to the artifact chamber. The air passes over a HEPA filter box before entering the artifact chamber. You may wonder why we need such fine filtration in a closed system. We included the requirement for the system filtration to trap particles that would enter the case each time the large front door is opened. Our HVAC vendor has a relationship with a local specialty filter manufacturer, and they knew this HEPA filter would function well in their system. While not the cheapest option, we do not anticipate having to exchange the HEPA filter over the life of the unit. Given the importance of protecting the Bible and the case glass from damaging or unsightly dust while ensuring good mechanical operation, this filter on balance seemed a prudent and cost-effective choice. The final thing to point out on this diagram is the yellow area to the right. This is the process section of the unit which holds equipment, including the compressor and condenser. As the schematic indicates, this process section is segregated from the airstream that enters the artifact chamber. This protects the Bible from HVAC components that generate heat and potentially can create smoke. We use several layers of data collection to monitor proper mechanical performance and confirm safe conditions for display. Data from the Rotronic probe pictured on the left in the blue box and located in the return ductwork is sent through the library's network to an externally hosted application called RMS. This provides 24/7 monitoring we can see remotely and sends alarm messages when conditions stray outside determined thresholds. We cannot use wireless monitoring equipment due to IT security restrictions as well as connectivity challenges in our building. T&D equipment shown in the red box allows us to collect data if the network is down. While we have to be on site to use the system, we can collect data without opening the back of the case, which is advantageous when the Great Hall is crowded with visitors. This graph shows the RH trend for 2021. With the exception of door openings, the case maintained an RH between 48 and 50%, despite surrounding Great Hall RH ranging from the extremes of 20 to 65%, with frequent and steep excursions. Recovery of conditions in the case begins immediately once the door is closed. Return to specified conditions happens within 5 to 8 minutes. As you can see from this graph, the temperature stays closer to set point when the door is opened. One change we made in the new case design was the removal of a non-aqueous fire suppression system that our predecessors thought necessary in the 1980s. Including suppression within a display case is highly unusual, but to be fair, the previous case had the HVAC unit plus other electronics within very close proximity to the Bible, with the compartments separated by a layer of marine plywood. While the suppression agent had been tested on cultural heritage objects, we decided to remove any risks associated with the discharge and to simplify testing and maintenance requirements for the fire protection system. The case employs two VESDA systems which constantly sample air from the mechanical and artifact chambers and compare the samples to programmed thresholds of obscuration, an indicator of incipient fire risk. Ports were installed in the respective piping loops, avoiding the need to access the artifact chamber during yearly system testing. The VESDA unit labeled in this slide reports to a building fire panel, which is monitored all hours by on-site staff. This type of system presents trade-offs. On one hand, air sampling is extremely sensitive, therefore it provides the greatest amount of advanced warning to inspect the case and remove the Bible should the situation warrant. However, our experience has shown VESDA sensitivity comes along with the need for far more maintenance attention relative to other types of smoke detection. On balance, the opportunity to respond before fire presents a more imminent threat seems well worth any additional maintenance nuisance. So what have we learned after the case has been operational for several years? Overall, we can report that the case is working as we planned and hoped for. Moreover, the case functioning properly results in less stress for our conservation team. The old case required not infrequent response to one component or another. The need to sometimes respond immediately, especially if after hours, was at times a weighty burden. I think as we all consider larger issues of sustainability, the ability to continually display a treasure like the Gutenberg Bible while minimizing pressure on the staff responsible for its care is a factor worth noting. And finally, this list names only a portion of the people instrumental to the design, fabrication, installation, and maintenance of this case. Collaboration is everything. Thank you all for your attention.